Telecom Douglas Productions and Svetlana Productions movie 6 coils transformer experiment in sky free energy hunter protections. Sponsor of program Douglas Hudson. Director of space Svetlana Hudson. Enjoy the movie.
Not so happy. Alrighty then, that was Happy 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 by the Fucked Tones. They're all fucked. And the lyrics are, we're so happy that we're not each other. Maybe we're not even slightly happy. So anyways, what we have here is the input in amps from the grid down here. 120 volts, 60 hertz. Here's the voltage across the light. Let me get this cord out of there. And here's the secondary over on this side this time, and it's made of Litz wire. 28 gauge, 12 wires in parallel, and it's 1.5 ohms, and it has real crappy induction, only 0.002 henries, while the primary is 5.2 ohms and 0.34 henries. The middle coil is 4.8 ohms, and induction is 0.42. So these have pretty good inductance, while this one has lousy inductance, but it's a step down. It's a step down transformer. I think the low impedance is kind of killing the efficiency of it. And I'm going to test this for a while, but I'm going to probably swap this out for one of these coils like this one. I have some wire. I hand wound these, and it only takes about an hour or so. Because this is a line reactor with this bar on the top, it comes off, and you can they're exposed, so you can just wind them from the top down. And that's why I have this clamp here, is to make sure this bar across the top is really tight against the top flat surfaces of these 3 AC legs. So, what else can I say? I did this yesterday, and I got a copyright strike, because I did a AC/DC song for like a whole minute, and they gave me a copyright strike. So I didn't get that up yesterday. But I did test it, and what you're going to see probably is about 42 ohms. 42 volts across these lights. And over here it's going to be 0.89, 890 milliamps coming out. And coming in, I think it's going to be like 390 milliamps and 120 volts. But this is with 2 lights, and I'm going to go with 1 light. It works better with 1 light, I think. And remember, if you saw my last video, when I put a 42 UF cap across the load, controversial cap I'll call it, because some people say, oh no, you can't do that, but it this is what puts the core into ferrule resonance, which is also something else you can't do. You don't want to do that. But that's actually one of the tricks to this thing, because the back EMF is sent from the primary here over into the secondary, down through the secondary, along here and back in, because when this is shorted out, it creates a pathway for that to happen where magnetic attraction pulls it. I've explained this before, but I'm getting better at explaining it. When you excite this, and let's say you're talking about just one half wave of the AC, let's say the positive half wave, if this happens to be north, the back EMF will be south, because everybody knows the back EMF is an opposite polarity magnetic force. So that's going to be, the back EMF is going to be south. Now, if this can be north over here, it's going to suck the back EMF in. And then it comes through and it goes back in the bottom of this coil. So it makes a loop of magnetism. Reverse magnetism. Hector calls this a reverse induction magnetic amplifier, because the induction is what makes power, and the induction is the magnetism flowing through the core, and it's in reverse flow direction. Okay, so what was I saying about all that? So when I put a capacitor across the load, and you can look this up on your favorite AI program, does a large AC cap across the output of a transformer, create ferrule resonance by shoving the phase shift very capacitive leaning. In fact, 90 degrees when I did that. It was on the scope, 90 degrees on the output to the light. That means there's no power being sent to the light, technically. And there's 90 degrees to the input. So technically, there's no power input either, because it's a 90 degree phase shift going in. So that's how it works, or how it doesn't work. So here we go. So I'm gonna, first thing I'm gonna do is not have this shorted out. You'll get to see what happens in unshorted coil here and shorted coil. Now Tim Tron in his video had a really big cap across the center, like I think 94 UF or 97 or something. But here I'm just shorting it. So, okay, it's now unshorted. I'm going to flip this switch and we're going to see numbers here. Here's the amps coming in. Amps AC coming in from the grid. Volts across in AC across the lights, and then amperage coming out of this secondary way over here. Primary's over here this time, secondary's over here this time, and this is Litz wire, 12 parallel winds of 28 gauge wire, it looks like. This is only 1.5 ohms and only about 0.002 inductance, so it's kind of a crappy coil. And I'm probably going to do a bunch of tests on it and then pull it out and put one like this that's about 4.0 ohms and 0.34 inductance. So get something in there about 15 times more, or is that more than that? 0.002 to 0.34 inductance. But I'm going to try this out. This is kind of a step down transformer. I'm just going to see what happens with this. So here we go. I'm going to flip this switch and you'll see some numbers pop up. Here we go. Okay, so coming in right now, 140 milliamps from 120 volts. The lights are doing nothing. I can feel the transformer humming. It only has 120 milliamps coming out and only lucky to have 1 volt, 0.9, 0.5 going to the load. Okay, so it's not doing much now, but watch. I'm gonna short this coil out in the middle. This is pretty interesting how this works. Oh yeah. Now the lights are lit up. We got 40 volts across the light. We have 400 milliamps in. Inputs 400, so it's about 48 watts in with 120 volts, you know. And coming out is over double the current, which you'd guess would happen considering this is a 1.5 ohms. Anyways, it's 0.89 amps coming out into the lights. So you can figure this right now. Four times 9 is 36. It's probably about 36 or 37 watts coming out as compared to going in. But I'm gonna okay, now I have just one light. Now it's only 200.2. And 440 milliamps coming out. Okay, so now we'll do something fun. Hold on 1 second. Okay, so we have that center coil shorted out. We're not really over unity now as far as the meters show. Okay, note it's 260 milliamps going, 266 milliamps going in, okay? 44 amps coming out, and we have 41 volts over the light. Okay, now we start tuning it. Now we're going to put in the controverisial cap, the controverisial resonant cap that also shoves the phase shift over to be extreme leading, capacitive leading. It, if you look on a scope, it'll be way to the left. So I'm going to plug this in and watch. The amps is going to go down. The volts will go up a little bit. And the amps is going to go up a lot coming out. So it's lowering the input. Timtron would call this, it's not only does this resonate the load and create a phase shift in both the input and output, but it's power factor correcting a little bit the input. So it's all good. Okay, remember that was 266? Now it's 214 amps in, so it's less watts draw now. The volts has gone up to 44, and the amps coming out is quite a bit more. Okay, so this is just a cap I picked out of my collection of caps down here. 35 UF. I don't think it's ferro resonating yet. Good, it's still going. Okay, so let me try a bigger cap here and see what happens. Note the numbers. I think this is somewhat over unity, about 24 watts in. Something or other, whatever this is times that is the output to the load. Okay, hold on one sec. Okay, now I put a bigger one in, 42 UF, and the amps is still low input. Well, the volts went up to 45 volts, and now we have more amperage coming out to the load too. This is probably somewhat over unity right now. 8, just doing real quick, 8 times 4 is like 32, 33 watts coming out into this load. Well, this is about 24. And so everybody's going to scream, well, what about phase angle? Well, when you do this, you put this cap over the load, the controversial resonant cap, it creates a phase shift, capacitive leading phase shift to the input, and it creates a capacitive leading phase shift of the same angle to the output. That was in my last video when I scoped it. So that's good enough, I guess. This is good enough. You saw what happens with the shorting. You saw what happens with the capacitor across the load. You saw how the capacitor across the load lowers the amp draw, and it raises the amp's output. So these are all these, I spent this week winding coils like crazy. I went to extreme high ohms and extreme low ohms, and neither of them are working out. So I'm going to probably use these for some other project. And I guess that's about it. I'm going to turn the power off. Okay, thanks for watching. I'm going to get Svetlana to say thanks for watching. Hold on a sec. Well, she took off upstairs or something, so I'll just say thanks for watching. And thanks for watching. Okay.